Good morning. I would first like to thank the organizers and Mr. Nabil for this opportunity to participate in this panel discussion about smart design of vehicles using simulation. During the keynote address in the previous session, Mr. C.V. Raman, CTO Maruti, has talked about various aspects of testing and validation for new materials for low weight design. Engineering design process has seen major changes over years, which I have myself seen in my career of 40 years, starting with manual drawings to CAD design and drawing making, from physical testing to digital design and computer aided analysis and simulation to predict the performance. I still remember my initial days in Maruti when there were no test facilities in house. We used to search for rough roads in Gurgaon for testing. That time, what the suspension modifications we were doing on Maruti van, and roads in Palam village for the big speed breakers for checking the road clearance of all the new models we introduced. The major problem we used to encounter was every time we used to go for the testing, the road surfaces were different. So we used to end up with searching for new locations every time. Of course, Maruti now has full-fledged test facilities and test tracks with all road surfaces for evaluating new models in-house and uses CAD CAE for engineering analysis and simulation modules for predicting the performance for different systems. Also, it makes me wonder these days during COVID lockdown when we are sitting at home and working, that what would have happened if we were not blessed with all these digital devices which are facilitating us to communicate and work efficiently from home without traveling to office. CAE and simulation of digital prototypes help verifying the design for compliance to various mandatory requirements, and if refined well, can eliminate a lot of physical prototype making at different stages of development, cutting short the development cycles and saving a lot of development costs. Simulation during the design phase of product development gives engineers the ability to adapt and react to problems much earlier. The benefit of this is more reliable validation, reduced costs and development times, and better performing products. In simulation-based product development approach, the direction of the design is to optimally satisfy requirements such as performance, reliability, sustainability, and cost. Hundreds of concept alternatives can be evaluated with simulation before detailed design is begun in very short duration. CAD and CAE and simulation together give the designer opportunity to optimize the overall design for large number of expectations, reflecting customer needs, and also check the regulatory requirements. We have an expert panel today with us to enlighten us with the industry practice. Would like to give a brief introduction of the speakers first. We have Mr. Anand Bhangaonkar, Executive Vice President and Head of R&D from Piaggio Vehicles. In the past 25 years, Anand has been working on several important projects, which include vehicle integration, CAE, product development, and leading key engineering functions such as analysis, design, testing, vehicle engineering, vehicle integration, and supplier quality engineering. He is also responsible for new product development strategies and the enhancement of R&D competencies for future. We also have Mr. Biswajyoti Mandal, Vice President Technology, Schaeffler India. Biswajyoti Mandal, Vice President Technology of Schaeffler India, is closely associated with designing, managing, and implementing organization-wide and division-specific technology roadmaps that support defined strategic objectives. Beginning with John Deere, he has been in the world of machinery for over 27 years, and he was head of the R&D of farm mechanization division of Mahindra and Mahindra before joining Schaeffler in 2018. We also have Mr. Vivek Kumar Jakhmola, President JBM Group. Vivek joined JBM Group as business head and president last year. He is driving synergies and growth of the auto component business of the Indian conglomerate. Jakhmola joined JBM from auto lighting company Lumax, where he was senior vice president and domain head for body emission and trim domain, where he also headed Lumax Mono and grew it to be the market leader in gear shift systems in India. Last but not the least, we have Renuka Srinivasan from Dassault Systems. She is a civil engineering master's from Duke University. Is currently SIMULIA sales director for India. In her current role, she is responsible for the SIMULIA business in India. Prior to this, she was WW Services Director for SIMULIA. Renuka has over 20 years of experience in the simulation business and was instrumental in setting up the SIMULIA business in India. She has worked with customers across a variety of industries, including automotive, aerospace, and defense, industrial equipment manufacturers. For kickstarting the discussion, I would request all the speakers to briefly explain the design process in their organization, the implementation of various digital tools, including simulation, and highlight the benefit they have experienced. So first, let us start with the OEM, Mr. Anand from Piaggio. Over to you, Mr. Anand.
Thanks a lot, Mr. Rao, for a quick introduction and setting the context for this conference. And I would really appreciate to be part of this panel and with my colleagues, industry colleagues here. As you outlined that I need to kind of chalk out what kind of a new product development process that we follow. As an industry, most of these OEMs do follow a similar V-shaped product development, right? From the product concept to conceptualization stage to a styling, then initial packaging studies that we do. And from there onwards, a lot of calculations and simulations are being done with the difference at the different phases and gates as our overall product evolves. Beyond that, once we start looking at it, the overall our vehicle model, we try to split that into the system as well as subsystem to a component level. So try and leverage a lot of MBSC technique that we have from the simulation perspective also. So we break that down to a system level, right? Model-based system level analysis also for the various function sciences. So when I say overall vehicle level function sciences, it is typically the NVH, durability, crashworthiness, or in primarily in safety, active as well as passive safety that we talk about, as well as multi-body MBD also, right? Having said that, what we also have done is a lot of forming simulations also to be done for critical components so that we can really import those all properties during the structural durability and crashworthiness models, right? So these are primarily simulation driven, all function sciences that we typically are using. As far as the engine and transmission is concerned, we definitely use a lot of GT power suits to make sure that we analyze and understand the overall combustion and engine performances also. This is primarily from the calculation and simulation perspective. Definitely in design as well as data management, there are a lot of other tools that we use at our end, primarily to manage our entire engineering data and then eventually push the engineering bomb to the manufacturing teams also, right? So there is definitely a bridge between the engineering and manufacturing, not only within our PLM, but then bridges to SAPs also. Having said that, now recently we have started simulating a lot of vehicle level and subsystem level Then EV models also. We have never relatively last couple of years, we have been using the system level or a vehicle level predictions and simulations for our EV vehicle performances to optimize and size all the systems like be it a battery pack or motor controller units also, and then predicting the performances also. So this is as far as when you are in the initial phase of design and kind of finalizing the overall subsystem and system levels and predicting the vehicle level performances. When it kind of meets our overall design targets, when we get into the major builds also. So there are different builds also, the proto builds, avant-series and pre-series. Different builds are also there for a different level of performance evaluations also. And then primarily with all the qualifications of gates, before SOP, we have a G7, G8 qualification, wherein the product gets into industrialization mode. So typically, this is what the process that we follow for any new product development that we are doing at our end.
So I just have one question, Mr. Anand.
Yeah.
Do you have readily any specific example to highlight how any of the simulation you have used helped you
Absolutely
accelerate the process?
Absolutely. So I will give you an example, multiple aspect. When we got into, I will give you an example of BS6 evaluation, when there was an entire powertrain change, underbody, and all components got changed, overall big subsystems level and system got changed. There was a task how we can optimize overall our vehicle level structural durability as well as engine mounts and overall the tactile vibrations. So what we have done, we have really acquired all the data while instrumenting our vehicle on our proving grounds as well as on the durability roads that typically that we follow. Acquiring that, we have built a lot of multi-body simulation models, extracted loads, and have done the structural fatigue simulation. Yeah. So that kind of predicts our overall structural durability, life of the components, or overall structural any chassis or body components or suspension components. Coming to the different engine mounts also, if I have to give an example, we developed from this data the overall mass table simulation also. So where we have done the virtual as well as the physical validation also on a mass table test, where the overall powertrain would go through the overall simulation as if the vehicle is running virtually on the proving ground or the durability roads also. As far as the EV is concerned, we actually have mapped multiple cities and their city cycles. We acquired that data and created the digital models to run our simulation for optimizing and sizing all the components and strategizing all the control parameters also.
I have one more question for you. Are you using any of the simulation packages for confirming the regulatory compliances during the design development stage? So without physical, testing, prior to actual physical prototyping, are you able to do that on your digital model?
On the digital model, I will give again an example of EV, right? There are the regulatory requirements of FAME2 to meet the certain level of acceleration, certain level of range, certain level of power consumption, which we are definitely we're able to use and predict with using our mathematical data and mathematical models.
So basically this ensures that when the physical vehicle is offered for homologation, there's no doubt that it will have any problems. And
absolutely. And I'm not saying that we have achieved what we wanted to achieve. We are almost, I would say, still away from 20%, 15 to 20% away from the prediction perspective when we our mathematical models comes into and then they provide us a simulation. But these are very good head starting points that we get it. And then from there onwards, our first few protos and avant-series builds will confirm. So that overall homologation timing would go down quite drastically, and we are very sure that we will meet all the compliance requirements.
What is the gap? What is the gap between the simulation values and the actual test values?
So if I have to talk about the typical function sciences where we have now for last 2 decades have graduated to a good level, I will talk about structural fatigue, right? Yeah. Wherein it is within 10% we are able to definitely predict, right? NVH also very similar. But now in the EV area, definitely we are 15 to 20% away from the actual reality, which we are trying to close that and then trying to
Okay.
graduate as we go along. Yeah,
Thank you, Mr. Anand. We'll come back to you again.
sure.
Next, we'll go to Mr. Biswajyoti Mandal from Schaeffler. Over to you, sir.
Thank you. I appreciate. So I'll put it short. Being a German company, Schaeffler, we have been working on engineering technology space for last 70 years. So in this last 60 to 70 years, we have collected a lot of engineering data. So that's one feedback or one input we have. That's one. Number two is that we are typically in the development of a powertrain in a different product and the system for a powertrain. It could be in an IC engine or could be in a BEV vehicle perspective. So when I look at this data and a different product that we have built it up so far, our data says in nearly 40 to 45% of the time for any product to be built it up, which is typically can take around, so far been taking around 3 to 4 years. Out of that 3 to 4 years, nearly 40 to 40% of time is taken by testing. So so that's a very large time, very big time. Around 40% time is taken for any product to be developed under the testing. Now, when we look at this, and there are continuous need or continuous demand from the vehicle manufacturer to shorten the product engineering time, so that how fast, how quickly we can develop the product. Now, we thought, if we really address to find a better processes tools, so that the 40% of the product testing time, which is typically take, if you can minimize in the tune up 15 to 20%, then probably is a very big saving in terms of product development cycle time. So that typically had been our typical focus for last few years. So how we can minimize the real-time testing and continue to do a lot of simulation practices. And when you're talking about the practices, which typically cannot be built in to run one testing after data acquisition of the data and things like that, it needs a lot of data, a lot of past data. So what we have been doing for last many years, we are trying to conduct different multi-body dynamics, discrete modeling simulations, and in line to that, we are also doing a correlation. We are trying to correlate for every calculation I do to ensure that there is a DVP we can put it together. The time we create a correlation in the tune of 98%, then we have a process that we document that as a DVP. So anywhere in the world, if you have to conduct that, we have to do that product, we have to build a similar type of a product. We follow the same process, same documentation, so that we do not end it up doing a lot of physical testing of the component. So there are multiple tools we have, for example, right from ANSYS, Nastran, LesDyna, CipherDim, and so on and so forth. And with that, there are a lot of in-house calculation tool also we have built it up. And with that process and with a different type of a DVP that we have built it up, I think we are making a significant progress towards the timeline to be brought back within a 20 to 25% time frame. So that's the kind of a progress we have been making so far. To give a real-time example, we also been working on certain product line to be developed, local product to be developed for the local market here for India. We have been working for certain product line for a two-wheeler and three-wheeler powertrain for a BEV perspective. And that product, different modular product that I've been talking about, it had been conceptualized, it had been inceptualized locally by India. And we have done or have been doing an extensive virtual simulation and also correlated that. And now we have already completed the real-time test. And the confidence is that there is not a single failure that we have seen so far. So this gives a very broad level confidence to us that different calculation we have put it before we build a prototype and test. So that is actually paying us back. And we have been able to build a very structured DBP processes to ensure that when you have to build a similar modular product for some other customer, we do not do a lot of actual testing and so on. So those are the typical processes we follow. And our typical goal is that how we can bring that 40 to 50% time, which is typically taken for the testing, to be brought within around 20% timeline. So that's our thinking process.
Right now, what is the gap you see between the simulated results and actual test results?
So the key challenge is that data, right? Data. So still, it's a long way to go. We are capturing a lot of data because every simulation testing we do, it has to be correlated. If we cannot build a correlated and then based on the theoretical, pictorial output, we cannot go ahead and build a confidence. So, and that needs time, because the time I do a CAE done and try to correlate with a lab environment, that takes a lot of time. So you made a significant progress, and many of the testing, CAE testing you have done, many of the testing we are reaching the tune of 98%, and there are few we have gone close to 75 to 80%. There are few competencies also we have built it up from the BEV perspective, BEV powertrain perspective, where we have been able to simulate the entire vehicle architecture and behavior of the powertrain, how that powertrain will behave if you have to put it into the vehicle, considering the efficiency of the motor, powertrain, and so on. And those competencies, confidently can tell we have grown to around 90% plus.
Is my understanding correct that you are right now having simulation and also actual physical testing?
So there are two things we are doing. As far as the CAE is concerned for a BEP topic, we are conducting both, right? We also have a goal. We also take a certain goal, 5 years down the line, we would like to launch a product from India where we will completely depend on the CAE and we will not do any physical testing of the component. So you have got, certain goal, certain product line we have identified. We would like to do completely 100% build up the virtual testing, and so that we do not do the real-time testing of the product.
That you are targeting for only specific parts? Or?
Yes. So that's, yes, for a few product line, we have been working for some time, last few years, building confidence, building the DVP towards that. And I think we are making a good progress. So one step at a time, we are taking one product line first. Let us see that how we are building the methods, tools, and the processes, and go to the market and see how the product is reacting to the market. Then the similar process, similar method will deploy to the other product line as well.
Yeah, are there any cases where your test results and when the system was tested along on the vehicle, the results were different?
Yes, there are few are there. For example, there are some transmission for a IC engine that we have been working for one of the Indian OEMs. Though we have done a significant CE there, but probably we have missed one boundary condition there. So the goal is that how we can understand and pick up every boundary condition. That's the key here. So if you miss one, gone. So yes, we have actually learned it from there, that one boundary condition we missed. And then when we had done the actual tested there with our OEM, the actual behavior of the product and the way it should behave, there is a big gap there. So yes, considering the boundary condition and see how we can understand the actual behavior of the product when the product goes to the real market, that condition, bring it back to this, the drawing board plays a very, very critical role. So we are into the process to build up that competency. There are a few cases we have been really very successful. Yes, there are a few gaps are also there. So building those competencies takes sometimes a long journey towards that goal.
No, extending this question, is the performance in the market in line with your actual usage on the road?
Yes. Yes, I think as far as the behavior, actual performance behavior of the product that we sell it to the OEM, I think the most of the product, or rather so far the product that goes into the market, I think there is no setback. It's only typically, since we are in a technology company, we jointly work with the OEM to co-develop the product. It is not a product we just come and sell, or from the blueprint we
Yeah.
manufacture and sell. So you co-develop the product along with the OEM, and during the build phase, I think those snags are being caught. So we closely work with the OEM if there are certain snag that we have missed to capture during our calculation process, and those are being caught during the proto build or during the testing before the launches. So when the product is launched, I think we did not hear so far from the India market that the product that we sold that has backfired as far as the performance is concerned, the behavior is concerned.
Thank you. Okay, we'll come back to you again. Thank you, sir.
Sure.
So over to Mr. Vivek.
We at JBM, we have both the sides of the coin with us. We are component manufacturers, where we are typical body parts makers. And we are also on the OEM side, wherein we have our own buses, where we are doing CNG buses, diesel buses, as well as electric buses. So I will just first take on the component side of it. Since we are making large components, and as the technology is evolving, the requirement for having the lighter and more higher strength metal products all around the body is growing every day. We do as high as 980 high tensile materials. We do a lot of forming and bending operation on these components. So simulation becomes an imperative part of it. It's very important that we must keep the development cycle time to the minimum, and the target is to have the first time right product always, and that is not possible if we are not able to reach 90 to 95% of the forming radiuses and the tooling simulation which we do on the sheet metal parts. Of what should be the radii, and what should be the impact zone in the die, and whether we need to give some air spring back, or whether we have to control the spring back, and those kind of things we have to simulate. So we do this simulation, and latest in the series of our efforts in converting into more on the digitalization side, we do have our own AI and Industry 4 separate division within JBM. So along with them, the project teams, they work, and they are going in for capturing the machine learning data. So a lot of data is being captured from machines. A lot of previous data. See, for the simulation, it's nothing but the lot of data should be available from the previous experience. We should have guys who are experienced in doing that activity, put all this knowledge into a software, and then demand the software that what will happen to the product. So what lacks here is that since this simulation and this thing is not very old, we are, although more than 35-year-old organization, we are doing this activity along with Maruti for many years now. Still the data entry for the previous experience, converting the experience of the engineers into a data form and using it as a so-called big data database. That is something which is a continuous process. We are quite well. We have almost reached at a certain level where a lot of information is available, a lot of boundary conditions we can set in, a lot of experience on the toolings and the behavior of the metal, which gives us the edge that close to about 90 to 95% we can do through simulation. And that is why the large dies, which are pretty expensive, we are able to save the number of attritions being done on the production side of it. So that's the part where that's a portion where the component manufacturing comes in, and the uses of the AI and machine learning and data collection transforming into the actual changes into the die before we actually manufacture the die. So that is the area where we capture in component manufacturing. In terms of buses, it's a very exciting area wherein a lot of simulation, right from simulating the entire factory before setting in anything, before setting up any machines and all, simulating the entire factory into 3D. That's a startup area. And going forward, then using the telematics and using a lot of data which the vehicle throws back to our systems for creating the benchmarks and for defining that what should be the crash resistance, which area is the area which need to be strengthened, and whether we can go in for some alternate materials by use of that data. My firm belief is that like mobile is there, which is now kind of a companion, digital companion for everybody for many years now. A car is going to be our digital assistant or entertainment system, or it is going to be only a mode of communication. So that's it is going to change. So it's going to change that it is going to be your entertainment thing. There will be a time where you will be using it for the entertainment. You will be using it for communicating with the outside world, and you'll be using it for gathering the data, the behavior analysis and all. So a lot of analysis, a lot of data is still being captured. What we lack here is the ready-made data available, which is being used or being captured by the other people. I think the service provider like Dassault system and all there, probably they can pitch in a better way, because every time the OEM has to walk its own path. So it will take some time, but I'm sure that if the data availability is better, the time to finally, when we are ready to go implement those things, can be shortened. So that's about how we are handling in component size as well as OEM side.
Hey, are you not doing any design of the buses now here? Right now, you talked about the factory design. No? Right
no,
now,
factory design we are doing the design of the buses, and there of course a lot of simulation goes in the entire bus designing. It's as good as designing a car or any other.
Obviously, yes, correct.
Yeah, so a lot of simulation goes in that, and whatever is there in the simulation segment is being used there. Starting from the component level simulation, where for the CNG buses, for example, we do the simulation of how much will be the weight of the vehicle and how much will be the efficiency in terms of CNG per kg uses, and then the crash simulations and even the ergonomic simulation that buses they're essentially a means of travel for masses. So how the people will be sitting, what kind of a gap should be, how the seat should incline, whether it should incline or not, and there are I think hundreds of simulation activities which goes into the bus designing. So that's the activity which is anyway is very exciting.
How close are your simulation results with the actual on-road usage?
So I would
especially
say
with reference to CNG consumption.
Yeah, we are one of our division also makes the CNG cylinders, and we are pretty aware of the uses and other things. The correlation between the weight of the cylinder and the CNG system and what will its effect on the ultimate mileage or the per kg kilometers, we can predict almost up to 90 to 95%. So we're pretty close onto that. But then it depends upon, like disclaimer is that it depends on a lot of other things, which still, that's what I said, that a lot of data would be required. How much should be the tire? So for example, if there are tire pressure monitoring systems made standardized, and the tire pressure can come in a real-time basis to the car computer, and then we can connect with the weight of the leftover CNG and the pressure. A lot of computation, a lot of data can help us in going more precise on that.
Hey, are you also using your simulation tools for development of electric buses?
Yes, simulation. That's electric is something which is I think we are typically the mechanical engineers. At least I am the mechanical engineer.
Yeah, I know. Yeah.
I think going forward, I don't know at which stage we will be put a obsolete tag, because electrical vehicles are more on a software side, and everything almost 80-85% of it is through the simulation only. However, still on the electrical portion, the battery is the main target. So simulation in terms of the space which the battery is occupying and the cooling rate of the battery, what kind of a cooling should be there, whether we should not be compromising on the weight of the side fins and aluminum structure and other things, and maybe the cooling liquid. So that simulation keeps going, but I would say that that area is yet to develop a lot. A lot of activities has to be done in that area, because still it is more to do with model based, I think, system engineering. So what we do, we make something and we create a digital twin, and that digital twin we try and put through certain simulations, and if that throws up some data, then we go to the physical twin and we do some changes, and then we try and see whether that in reality it is throwing the same figures or it's a different figures.
Thank you. We'll come back to you again. Over to you,
Sure.
Renuka.
I would say when it comes to the usage of simulation, the automotive industry is perhaps one of the most advanced, maybe with aerospace would be the only other one where we see extensive knowledge, exploitation of simulation technology. From our side as as people who develop and work with our customers in creating what we feel are their end user experiences. We focus a lot on providing the right technology to enable this kind of what we call predictive realistic simulation. So that because the value of the simulation is there only when it becomes predictive, as we saw in the previous comments by all the other people there. From our side, Dassault has focused quite a bit on enabling this model-based systems engineering. It is something that we strongly believe in, and we want to give people a platform where they are able to start with the requirements and then flow through the functional logical process. So we work quite a bit on that. We also today, I think, we believe this is simulation has become more about multi-scale and multi-physics. A lot of people spoke, in fact, Mr. Vivek mentioned about being a mechanical engineer. I think the thing is today the car has so many different physics going on. And not only that, with the battery, with the EV aspect, we also cannot work in independent silos. We need to work with each other to understand the overall behavior or the physics that is going on. And so we focus a lot on the multi-physics aspects, whether that's looking at electromagnetism, acoustics, or fluids, structures, all of these domains, and how do they interact with each other. More importantly, how do we ensure there is a seamless communication between these different domains, so that the engineer is focused on the end result and not worried, about the integration itself. In the past, what we found is people spend most of their time just trying to get maybe acoustics code to work with a fluids code, etc. And what we're trying to ensure is a seamless way to do this kind of multi-physics simulation. So the focus can be on the innovation aspect. Similarly, for instance, with the batteries or with other areas like additive manufacturing, etc., you start getting into multi-scale, because you might want to look at something at a molecular level, and then you might also want to understand what's its behavior at a continuum level. Again, when you're looking at things like battery packs, or I think some of my colleagues also spoke about vehicle level, you might want to look at something at a 1D level, you might look at things at a system level, but you might have one or two components where you're looking at a very detailed 3D physics, continuum level at what is happening in that behavior. So I think we focus a lot on ensuring that this kind of multi-scale, multi-physics simulations can be done in a seamless manner. We also focus on having a platform where this kind of collaboration can happen across domains, because I think in the past we've had a lot of silos, whether that's modeling, simulation, and I would say even in simulation, you have a durability group, you have an NVH group, you have various groups, and when we are looking at ultimately a trade-off study, we need to have all of them speak to each other in a manner that they can understand. And this kind of seamless collaboration is another aspect that we feel with a platform approach we are able to bring that to the table. And lastly, even to look at something like a trade-off, etc., it's very important to have robust industry practices. I think Mr. Mandal kept reiterating about how they do, some level of testing, validation, and then they add an extra layer of complexity. And that's really good. That's the way that people build up these best practices. And as people who work across, industries and across geos, we have tried to put in what we call industry processes, which help in guiding and ensuring, some of these processes are already in our system. And of course, people then customize or add on to those processes based on their own practices. So I think these robust industry processes are important, because only when you can put down those best practices, you can have the consistency in your result. And you can also then look at maybe automation and get then into optimization or design exploration studies, where you can then look at what happens if you have a temperature variation because your battery, you have a vehicle in Delhi versus a vehicle in some other part of India and the temperature changes, or you want to have other conditions and variations you want to look at. So all of this is possible once you have that industry process. And then you can look at the trade-off studies. And in some cases, further, what do you want to take into account at a manufacturing process level? So I would say from our side, these are some of the aspects that we focus on. And of course, today, everyone wants to be connected. I think luckily that was something that had started earlier, because today with the pandemic, we're all working from home, and, product design or development has not stopped. And that's because we are able to access these simulation tools on the cloud. We're still able to run large simulations. And I think that's again something that we are able to provide, so that our customers are able to continue with their product development. You were asking about, what's happening in some of the other geos. One of the things we saw was during the lockdowns, people could not do physical testing, but therefore they increased their reliance on the virtual testing, and they were trying to ensure that there is more virtual testing going on, and they're being more rigorous about that, and including maybe more workflows into their studies, because they had to compensate for the fact that they were unable to do physical tests during certain strict lockdowns. So this was again something that we did see. And of course, we are seeing a lot more usage of cloud as well, both just given the HPC capabilities available. But I think the pandemic has also ensured that maybe some people who had some resistance or some concerns in the past have kind of really adopted this technology and leveraged it. So that's what I had from my side.
Thank you, ma'am. Right now, during the COVID lockdown, most of the activities could be delivered from, could be done efficiently, or rather more efficiently, sitting from home. However, the manufacturing people had to go to plants. So I have this question for Renuka. If you superimpose the future, what we are talking about, 4.0, Industry 4.0, IoT, and machine learning, etc., with fully automated manufacturing system, do you foresee a day when even manufacturing will happen without the physical presence of any workforce there? Has it happened in any other country?
I am not aware where that has happened, but certainly I think IoT makes it very interesting, and it is certainly possible. And that's where also the concept of the digital twin, or we call the 3D experience twin, is possible, because you can then, get your feedback from the sensors or whatever is, at your actual factory, have that information brought into a centralized location. I think that kind of information coming back to a central location, people looking at that data, some of that is already possible. I'll have to check whether someone has actually done without anybody in the factory, but certainly you do hear sometimes of what they call, I think, dark factories. I'll have to recheck that, where the idea is that if it is completely automated and, with robots, then it is possible that you don't actually have a human over there. From my side, though, I would say that the digital twin or the 3D experience twin is something which is quite exciting, because in a way, simulation has already always been virtual twin, right, of the real world. But by adding that extra layer of the connection to the physical world, then you can actually get the information. And I think Mr. Vivek had also spoken about it, that if you can actually get, for instance, your tire pressure, and that information comes back to you, you could perhaps do simulations and understand what you're seeing with respect to tire wear, or how is your handling going to change because you have certain tire pressure. And then does that mean you now need to, in a connected system, send a warning to a driver that there is an issue here and maybe some predictive maintenance needs to be done. They need to stop and have that pressure checked. So that kind of capabilities, I think there are a lot of innovative capabilities that are possible. And like you spoke about, both with machine learning and artificial intelligence, there's a lot of work that people are exploring and trying to do in terms of how can you maybe speed up simulation, how can you look at maybe reducing the number of full-grown simulations you need to do, but maybe do some kind of a reduced simulation based on previous machine learn, previous data that you have, but still explore the entire design space so that you can save on the runtime perhaps related to each simulation that you would do, but continue to explore the design space. So I think there's a lot of exciting things coming, which we will see coming in the next few years with machine learning, AI, leveraging big data.
Thank you. Thank you, ma'am. The COVID lockdown, most of the activities other than manufacturing happening from home. And also the various technology changes happening because of government push towards electrification of automobiles, and also the emerging areas of autonomous, connected, and shared vehicle requirements. We are seeing a lot of changes happening in the automotive technology requirements. And also our Prime Minister is pushing for Atmanirbhar Bharat and expect India to take a leading position in auto sector, not only for manufacturing vehicles, but providing innovative solutions to others. Especially the Niti Aayog and other the policy makers think that our involvement in developing electric vehicles in different segments should give us a lead over other countries because of the size of the country and you youngsters who are very innovative, who are doing so well in other countries, and also the fact that a lot of these youngsters have started getting into their own enterprises to come out with some innovative products. Do you what are the changes we need to bring into our design development process to accelerate the whole development, and also what other simulation tools we feel would accelerate this thing? I will start with Mr. Anand.
What you actually, there are multiple points that you have thrown in.
Yeah,
this, right?
Basically,
so I would try and address a couple of those, right? And then I will leave
it to
my
others.
colleagues to address some of those, right? Yeah, that would be fine. Coming to the all sorts of aspiration coming from Niti Aayog or PMO, right, for any new venture, which is BS6 is one of the good example that we have graduated from BS4 to BS6, right? But having said that, while we are aspirational for that, we all are here for the business, right? That government also should realize it, because immediately they have thrown us ethanol based and blah, 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 right? EV based also, we all as an industry, we are for it, right? We do see that there is an impact on environment, but then there is a certain level of huge investment that we have done in BS6, right? A lot of design development, even acquiring these competencies and tools for simulations also. I will give you an example of single cylinder diesel, right? We never had any engine or technology outside of India even to comply to BS6 kind of an emission requirement. So once we invest into all these types of simulation and all other tools, it is very important to have the ROI from that business. Coming to the other part of that, right? So this is where there should be a structured way of going through the
Migrating.
change and then right
Migrating, yes.
graduation from right migration, and that should come from properly from Niti Aayog. Yes, there are a lot of aspirational things that I want as a country we would like to go there, but then at least like I would take my example. We are into the business of last mile connectivity, right? So we are the first one to get impacted immediately as a target to convert and migrate to EVs, right? I just graduated to BS6 last year, yeah. And then within 5 years, if I have to go to EVs, yes, we have, while doing that, we have definitely done, and we have created a product portfolio in EV. We are the first one in the last mile connectivity where cargo as well as passenger that we have done. We have invested into EV. There is a future, and that is the future going forward also. But having said that also, we still are dependent on a lot of technology as well as material supplies also. And we are not Atmanirbhar there, right? So, okay, we are trying to be Atmanirbhar against the petroleum products, crude, right? But then from the cell perspective, I'm still dependent on somebody else. But having said that, we are graduating there, right? Yes, there is a big market, especially 2-wheel, 3-wheel, and buses would be a good potential for EV. Let's see how quickly we can adapt. We have been thrown as a target also, right? 5 years and 10 years, we should migrate to 100%. So that's where, as my colleagues have said, right? While doing a lot of and implementing this simulation data, we are generating a lot of data for ourselves, and that itself, data handling, getting the sense out of it, right? That's where we are in that phase right now. How can we better utilize it? Right, coming from telematics, coming from IoT, right? All of this piece of information we are putting together, and then how can we really create very innovative but cost-effective solutions, especially for our segment where we are doing business, 2-wheel and last mile connectivity.
Yeah, I agree with you. And actually, pressure for electrification of 3-wheelers must be very, very severe, because that is the segment where everybody feels that economically it's viable case, and the penetration could happen very fast. More so because the 3-wheeler diesel version variant is very, very costly because of BS6 implementation.
Absolutely.
So this factor, that's why electric 3-wheeler becomes very viable proposition. And I think the migration to electric 3-wheelers would happen much, much faster compared to other segments. Yeah. Anything from Biswajyoti or Vivek on this issue? Yeah.
So I'll probably address two topics here. One is the current trend, right? Technological changes that you look at on the ICE products or vehicle that you see on road. There is also we see a rapid technological changes demanded by the OEM. And what is that? So the OEs, they want the product, any product to be given to them with a very compact in size, lighter in weight, which was not there few years in the past. If we,
very low cost.
So in my calculation, all my calculation, if probably few years back, if I would have considered a factor of safety of 2 or 3 or 4 and build the product and test the product and give it to the OEM, they will feel very happy to take the product, because if I consider a transmission, the place that I get inside the transmission to make some new component, bearings and things like that, the way the space was there 5 years back, the versus they give the space now, it has come drastically low. And at the same time, the OE is telling this part has to perform for the entire life. As long as the vehicle has got a life, the bearing also has to work. There is no changes. We don't want the bearing to be changed in between. So one change I see that every product OE is demanding, they want the product got to be built for life, entire life of the vehicle, number one. And they have also minimized the size to be given and price, the connected price for that. And that is a very big challenge, very big kind of a technological trend on the current product line that we see here. Now, this gives a lot of back pressure on our design, calculation, and simulation. if you have to design a product with a safety factor of 1 or 1.5, that means every calculation simulation has to be near to perfect. It has to be near to perfect. There's no chances that you build a product and then you give it to the OEM and then it does not work. So that is not going to work. So Vivek has talked about first time right. So that's a very critical and important parameter, considering with it the space, cost, and the technological changes we see on the current product. So that gives a pressure back to our calculation and the simulation, better processes to be built up, better DVB to be built up, better correlation got to be built up to make sure we design the product considering safety factor close to 1. So that's number 1. 2, in the past, we had a car, we typically still have a car, which is a mechanical device, So IC engine, diesel, petrol, power, vehicle goes. So the changes that you see here with time, the vehicle is no more a mechanical device. It is a mechatronics device. It is not a software device, neither a electrical device. It is a mechatronics device. So that means mechanical excellence has to be there. The vehicle has to be as light as possible as the mechanical material is considered, safety factors are considered. That's one part. At the same time, the basic intelligence has to come from the software. So that means that this brings a new competition to be built up for all the manufacturer, including the vehicle manufacturer or maybe technology company or tier 1 supplier as well. Do we have enough competency on embedded system, or we still have mechanical competency lying ahead as the technology changes are happening with time? Now, when we're talking about this, we're talking about this country as India, we're talking about EV. I think Mr. Anand can possibly talk more. Currently, that around more than 40 to 50% of the product cost, the vehicle cost, come from the battery. The time you consider the cost of the vehicle of a EV vehicle versus the petrol vehicle, there is the cost of this battery of the vehicle is far ahead, far more than a petrol vehicle, and that is primarily coming from the battery cost, which contributes to a very large extent. India being a country where a cost sensitivity is very high, probably time will tell percentage of growth on a battery operated vehicle in India, how soon that will happen. So that's one part where to take a note exclusively for India. Now, when I talk about that, we also should kind of touch upon, is the EV is the only answer we have, talking about a different dimensional technological trend that we're talking about, where battery cost has reached probably $140, $130 to $150 per kilowatt hour. So is it the battery? Is it the EV is the only answer? I think there are a lot of experimentation already has started to happen in India on a fuel cell, right? So whether you're talking about a fuel cell, kind of a hydrogen fuel cell or battery operated vehicle, the entire intelligence of the vehicle will come from the embedded system. And that gives a new dimension to every vehicle manufacturer, including the tier one component supplier as well. How soon we also can have this additional competency on a embedded system. That is what we can put it together in a broad level platform called a mechatronics system or a function to make the product that we build it up, whether it is a battery operated or a fuel cell vehicle, as we becoming more, the kind of percentage you are looking at growing number bigger in this country. So that's what I thought to be shared here. Also quite important topic.
Mr. Vivek, any comments?
So I think it was very well covered by the analyst. But I just have a few views which arise out of my experience on EV. So basically, conversion from IC engine to EV vehicle, as everybody knows, chicken and egg story, whether we should convert first and then we should have the infrastructure, and we should have the infrastructure and convert first, convert later. It will still take some time and maybe some technological innovation, but be it change from lithium ion to solid state battery, or some new technology which is coming in. The range anxiety, if that can be addressed, and if the cost can be reduced, these are the two questions which are very prominent. But I think these questions can be answered in multiple ways. Range and anxiety, answer is not that we just create a battery which has got 1,000 kilometers range. Answer could be in many ways. There could be swapping method. There could be, especially for the commercial vehicles, it's not such a big issue, but they normally have a fixed travel distance, and they always come back to their charging point. We are successful in JPM in electric buses. They normally have intracity travel, and this is basically a fixed route. So we exactly know how much is the range which this vehicle is. So if you add a factor of 20%, 25% extra, then that should be fine for these vehicles. But to move it further, I think the first thing which is required is the absolute clarity in the Government of India policy, what they are going to do in next at least 10 years time. And it should not happen that with the change of the government, the policies will change, or change of some it should happen that I will buy 50% vaccines in the month of May, and then next month I'll buy 75%, and next month I'll buy 100%. So those there should be a firm policy in terms of electric vehicles future going forward. Once that happens, then the determination and the clarity and the long-term vision in the OEMs will come in. Only then OEMs can align, and then comes tier one, where I think most of the things ultimately lead to either the push and the demand from the OEM, or the high level of commitment to adopt this virtual methodology by the top management of the system. So I'm talking about typical tier ones in India. So that whether the vision of the management is it a long-term vision where we assume that not only we will create the resources, not only for the mechanical side of it, but for the mechatronic side of it and for the electronic side of it. And going forward, will I have the people in my design and development team who will be not only from the mechanical engineering side, but I'll also have a simulation guy supported by a data analyst, by a AI guy, and by a system, data scientist who is combining all these things and then creating a base for me to take on the next level of simulation. So this will all depend upon that, how far we want to travel in this area. So that's it. I'll just keep it very short. Thank you.
To address to some extent to point what Mr. Biswajyoti and you have raised about electrification of automobiles. Terry has done a lot of studies on this, and our findings say that you cannot apply same formula for all segments of it. Different segments need different treatment. And as I mentioned earlier, like three-wheelers case is very, very good, very positive for electrification, because the battery cost is not very high because of the size of the battery they are using. And also, as most of the three-wheelers are used for last mile connectivity, the range requirement is also very limited. So and also economically, the price of a electric three-wheeler is comparable with the IC three-wheelers. And next in line is the two-wheeler. Two-wheelers also, it's possible to, with some level of push from the government, I think two-wheelers also should be possible to make the case viable, where the battery charging can happen at home. And also, of course, it has to be supplemented with some public charging stations which have to be set up. But major infrastructure is not required for electrified two-wheelers, because the battery can be, lifted and carried home for charging in the night. And also, typically, two-wheeler users don't use the vehicle for more than 100 kilometers in most 99 percentile cases. So the so-called range anxiety is also actually imaginary, virtual thing. It's not real. So, I think these two segments will happen fast. But however, having said this, some analyst has predicted that two-wheeler electric penetration will be 60% by 2030. if you look at what is the status now, and even if you consider there is no growth in two-wheeler segment for next 10 years, the requirement of 60% electric vehicles by 2030 would mean almost 12 million electric vehicles. When we are now at 1.5 lakh vehicles production in 2021. So it's a very, very rapid progress, which I mean, people like us feel that it's not, possible. Such a fast penetration may not happen. So I think IC vehicles will be there for a long time till actually, as you also mentioned, the battery prices come down where it will make all the segments viable, and also the OEMs will come out with more and more electric vehicles to choose for the customers. Madam, you want to add anything? In terms of, I just have one question.
Sure.
The simulation packages, what you have, is that what you have, or are you planning to have more to facilitate some other aspects of evaluation of systems or the vehicle as a whole?
So I think today itself we have various solutions which handle the EV at different aspects. So we already have things which do system level analysis. For instance, we have solutions like CST Studio Suite, which would do the electromagnetic parts. So if you wanted to look at that, if you wanted to look at the electric motor for the low frequency, we have solutions for that. We also have at a battery, at a molecular level, if you want to see how the lithium ion is behaving when you're looking at battery cells, then we also have solutions towards that. Of course, we are constantly also developing as based on what we are seeing as the needs. We work with, industry, we work with professors, and of course, even our own in terms of adding to technology to capture a lot of these behaviors. So I would say that today, if you, for instance, take the battery, we can actually go from, looking at it at a molecular level, then looking at 1D simulations, looking at battery aging, how degradation is happening of the material, thermal cooling of the battery pack. All of these different kind of simulations, I think, are there. But of course, this is an evolving field, and we will continuously be updating, what we have based on, what we see with the industry need. And in many times, we work with the industry to develop processes that, based on what they need, we implement those. In fact, today we already have something we call the Electro Mobility Accelerator, which is kind of certain best practices and industry processes for EV workflows. Basically, because we do see, this is a big trend, obviously, in the automotive industry. So whether it's startups or established companies, there is a lot of focus on this area. So I would say we already have solutions, but we continuously work to also update those. So I think from a
Thank you, ma'am. I think you have already crossed the time given to us. I have one observation for which I want all of you to react. Ultimately, will a stage come in simulation when using the digital mock-up, we will get not only 100% evaluation of various systems, including durability, and also get homologation done digitally. Has this happened in any other country or happening in any country? And you think this is a possibility? I would like to hear all comments from all of you. Anand, why don't you start?
Yeah, what I would say is whether we will be very close to that aspirational level, yes, absolutely. But just one step before that, we will stop. We will have the physical vehicle made before, and then we will type approve, right? As a system level, some of the system level we are even today qualifying, right? But on a full vehicle level, because there are, from the same year regulatory perspective, there are so many full vehicle level tests are there. So those, not only us evolving with the simulation, but overall as a certification agency also, they need to graduate, and then they have to accept, because now you're talking about a global mathematical models for all OEMs and blah, blah, right?
No,
so that's where from that aspect, if you are talking about.
I'm talking about a time when, of course, the certification agencies also have to accept this, but
Correct. But
it
as
would
far as the
also
system,
mean that the digital model and the simulation
so
systems
already,
what we have are perfect in terms of giving the
so if you
perfect answer.
really ask me, are we there yet? Absolutely. We used to have multiple builds, right? Now
Yes,
we have
exactly. Yes.
only one or maximum two. That's about
Yes,
it. And
yes.
even in future, it will be only one, and that's where that physical
Ideally,
vehicle
it
will
should
be
be
built.
only
And
one, I think.
that's about
Final.
it. So we are very
Yeah.
close. In next 5 years, we will be there.
No, my question was with reference to more to do with certification.
Okay.
Do you think that's a possibility?
So today we are doing it on certain level of systems, but on a vehicle level, as I mentioned, right, there would be a lot of evolution that we have to do.
So why I'm asking this is what I understand about commercial vehicle fuel economy norms which are being set up. I
Yeah.
think there is not through physical testing, but it's through some mathematical model. So if that is possible there, why not for whole certification? Ma'am, would you like to comment on this?
So I would comment on the first part which you said, which is the fuel efficiency part, right? So you're right. So with things like WLTP, what we see is that they do accept, the regulators do accept a virtual test because you have to look at all the different variations. But part of that process also requires them to certify your virtual process. So it's, and so that I think will be what, Mr. Anand was trying to say, that is to do it for a full vehicle, then they will actually have to certify your simulation process also for all of those different angles. Today, I think it's, we are already doing virtual simulation and getting certain, like you gave the example of WLTP, where you can get away with the virtual simulation. For doing it at a full vehicle, you'll have to work with the regulators. We're not there yet. But I think it is more, like you said, about working with the regulators and having to have all of those different tests virtually, your best practice and your method certified by them. So I think we have some way to go there. From a certification viewpoint, I think from a simulation viewpoint, simulation companies might be a little more.
So is this part of your vision?
I would say certainly we do have a lot of companies which talk about zero prototyping, but typically, like you said, zero prototyping literally usually ends up meaning one prototype.
Last one,
that final one which you actually test.
Pre-production, yeah.
And every time you go into a newer area, for instance, with EV, with ICE, you have 100 years of experience. With EV, you don't have that. So when you go into a new area, you're going to have to again build up.
Restart from scratch.
Correct. That's going to happen.
No, sorry, I have one more question. Your simulation packages, whatever you have for vehicle level simulation, will they hold as it is for electric vehicles also, or you have a different set of packages?
No, so these are general purpose packages, and they would have, capabilities for certain materials, right? So you have the capability to do, say, vibroacoustics, or a capability to do crash. That is still going to be the same, whether it is an EV or it is ICE vehicle. The only thing might be now you're doing some additional new workflows, or you have some additional new materials. So like for the motor, you will now have to go into a different kind of design, and there you might have the electromagnetic module or the to be added if you didn't have it in the past. So
I think one of the major issues we are going to face in India is with reference to the battery, because we have extreme environmental conditions and also so-called water flooding into the vehicles in heavy monsoon time in cities like Mumbai and other places. So, I mean, this is something which would be unique for India, and the battery performance under such conditions, or what safeguards we need to take to prevent any problems on the battery, would be unique to India.
Certainly. And I think that's again where, the environmental data with respect to what is your ambient temperature or how is that temperature changing, because over a long drive, right? How does that change? Because the battery cooling becomes very critical. The other aspect, for instance, is I live in Chennai. You're typically turning on the AC. That again impacts your battery,
Yeah. That's right.
right? Because so much of that power is then goes into the climate control. So all of these will impact, and in our case, it will be much more, perhaps.
Thank you all for excellent discussions and thought-provoking inputs. Uh, I would like to thank the organizers for giving me this opportunity to moderate this panel discussion. And I would like to thank all the panelists, Mr. Anand, Mr. Biswajyoti, Mr. Vivek, and Mr. Renuka for their active participation in the panel discussion. Thank you very much.